right, welcome to 2.5a, and this is Gauss-Jordan elimination and solving systems of equations. And so where I'm going to start this set of videos is translating systems of equations into matrix equations and then eventually into augmented matrices. So this is the first step that we need to do in order to be able to transform or to work with systems of equations using Gauss-Jordan elimination and matrices. So let's imagine that what we have is we have x1 minus x2 minus 5x3 equals negative 3. Then we have 3x1 plus 2x2 minus 3x3 equals 5. And we have 2x1 plus 0x2 minus 5x3 equals 1. So a couple of things that we want to get here is currently right now we're not inside of any kind of matrix form. And so using Gaussian elimination is not going to actually be effective for us. What we need to do is we need to transform this into a matrix. And what we should notice is we're going to take these values. We're going to call this matrix A. A is going to equal all the coefficients in front of the variables. So we'll have 1. That's the first coefficient in front of x1. Negative 1, negative 5. Okay? And then 3, 2, negative 3, 2, 0, negative 5. Now, if you don't have one of these variables, I actually filled in a 0 right here, then you're actually just going to use 0 as a place marker. This is called our coefficient matrix. And we have a vector, we're going to call it B. It's going to be our solution vector, and it's negative 3, 5, 1. Now, you might be asking yourself, what happened to x1, x2, and x3? Well, x1 and x2 and x3 are actually going to be a vector as well. So we're going to take 1, 3, 2, negative 1, 2, 0, negative 5, negative 3, negative 5. And if we multiply that by x1, x2, x3, we get that equal to negative 3, 5, 1. And just to demonstrate that the two are in fact the same, we're going to use matrix multiplication. So 1 times x1 is x1 plus negative 1 plus x2, so that's minus x2. Negative 5 times x3 is minus 5x3. And then that's going to end up equaling negative 3, because basically what we've done that multiplication, and it'll end up being negative 3. Then we have 3x1, 3 times x1, plus 2 times x2 minus 3 times x3 equals 5. And then we have 2 times x1 plus 0 times x2 minus 5 times x3 is equal to 1. Okay, and you can see that this equation right here is the same as that, right? They're just in different forms. This one here, this is either called the vector equation or the matrix equation. Now what we're going to do is we're going to further condense this. So if you've watched us do systems of equations, what you'll notice is that the only things that change are in fact the coefficients. That none of the variables, right, none of these variables in here, okay, right, they don't actually change. The only things that change are going to be the coefficients. And so we'll have a third form, which is called the augmented matrix, which is where what we're going to do is we're going to take that coefficient matrix, 1, negative 5, 3, 2, negative 3, 2, 0, negative 5. And we're going to put a little dotted line there, and then we're going to have that solution vector, negative 3, 5, 1. And running it like that will then allow us to, in fact, use Gaussian elimination completely and solve the system of equations. Okay? Right? And what we've done is we've eliminated the variable vector, right? And what we'll work on is we'll work on then reinterpreting, once we're finished with Gaussian elimination, what that solution actually is. Okay? So we'll rewrite it back again as a system so that we get our solution to the system. So